Today I want to explain you about the star clusters. Let me share my screen. You see here about the n-body simulation. We have different source of study that you see. Also for dark energy and complete overview, as you see, the gravitational n-body simulations from Cambridge University Press and others. But what is n-body simulation? Simulating the interaction of n objects in a system, no limitation of interpretation, and examples are movement of stars under the influence of gravity in a galaxy, star cluster formation, and clusters of galaxies. We can say, for example, for n-body, it is, for example, for if 2 or 3 or 4 or many or n body or n stars go in their ways and suddenly they see each other and their gravitation attract each other and they capture each other and they form, for example, binary stars system and or 3 or 4, we call it n-body, and it has no limitation of interpretation. And just we can have it in star clusters or in other science. We can use the n-body simulation. For n-body, we need mass, location, velocities, geometries, and other properties. Basic n-body simulation is start with the n bodies, initial position and velocity. For each time step acceleration of each body is calculated. For example, based on the influence of gravity, velocity is updated based on acceleration, and position is updated based on velocity. How to update the position and the velocity? The simplest update step is a forward Euler algorithm. As you see here, Ri plus 1 goes to Ri plus Vi dt, and Vi plus 1 goes to Vi plus Ai dt. Not very accurate, but for the time step dt, a body is moving in the Vi direction, only correct at time I. Leapfrog algorithm, position defined on integer time steps, velocity defined on integer plus half time steps, velocity updated by I plus 1 over 2. The approximate value of A halfway between time steps I and I plus 1. And you see here, for example, Ri plus 1 goes to Ri plus Vi dt plus Ii dt square over 2. And Vi plus 1 goes to Vi plus Ii plus I plus 1 and dt over 2. And for parallel n-body methods, we can see the fast multiple method and the Barnes-Hut algorithm and parallel multiple tree algorithm. And here you see someone do the simulation of universe, or they said it is from our universe, but as they input the physics or the data, maybe they will be changed. They change now. Maybe it is a simulation of a universe, not maybe our universe. By the way, they input from data from 1970 until 2012, and in 2012 they make a simulation of the universe. And you see the groups that they collaborate in the simulations. Thank you for your attention and see you next time. Bye.